This is our Salamander Diversity Research Project in streams across the campus of University of Richmond.
Our goal for this project is to discover the biodiversity of salamanders in streams around the University of Richmond's campus to determine the condition of the University of Richmond's natural environment. We wanted to consider the effect of recent construction on campus, but unfortunately we could not because there's no prior data of salamander biodiversity on our campus. We could have considered how construction affected the campus environments because salamanders are extremely susceptible to environmental changes. Salamanders represent a large portion of vertebrate biomass in terrestrial and aquatic ecosystems, and they are very easily detectable. Any changes to a salamander's environment, such as a change in temperature, pH, or humidity, can have a very significant effect on the population. This makes salamanders an effective indicator for environment health because they are very commonly found, and as we said, they're very susceptible to environmental changes. Our hypothesis is that we expected to find a lot of salamanders of the two species of the southern two-lined salamander and the southern dusky salamander. Finding both these salamanders would be a strong indicator as to whether or not Richmond had a healthy ecosystem. Construction very negatively affects salamanders and their habitats because of many different factors. Roads and other urban structures can isolate salamander habitats and force said salamanders to inbreed, causing them to lose genetic variation, which is crucial for their survival. Also, larval salamanders can be flushed out of streams due to water velocity increasing from overflowing storm drains and the water running too quickly for larval salamanders to remain in these streams. The urbanization of terrestrial environments can also add sediments to streams, ultimately deepening these channels too much, which drastically affects stream ecosystems and makes them uninhabitable for salamanders. We were concerned that all the recent construction on campus would harm salamanders in the ways we just listed. We designed our study to include multiple ages of salamanders, larval and adult, because for a most accurate study of stream amphibians, research should be conducted on more than one life stage, because conducting research on only one stage may lead to inaccurate data, which is why we sampled adults and larval salamanders. One life stage of salamanders could just be more responsive than the other to environmental changes. Therefore, if we were only to sample one salamander life stage, we wouldn't be able to tell whether or not the environment was having a significant effect on them.
We collected data in the eco corridor and the various streams within it. The stream under the bridge near the intramural fields, the stream behind the lodges, and the stream behind the baseball field running into the lake. The eco corridor contains Little Westham Creek and the surrounding land. Over the past couple years, University of Richmond has constructed and restored the stream as it performs critical functions for the watershed of Richmond. As a result, we wanted to test the salamander diversity to see how productive this recent stream restoration was for the ecosystem and whether or not it harmed the ecosystem. We collected data every Monday and Wednesday for 4 weeks for at least an hour and a half every sampling day. So we used a hands-on method of flipping rocks and scooping salamanders up with a net or our hands. We started by using a net, but it proved to be too difficult to scoop nets where rocks were flipped because they were too large. For every salamander we collected, we recorded the coordinates, date, time, temperature, humidity, weather, age, species, quantity, and sex. In total, we found 61 salamanders, 32 of which were two-lined, 21 were northern duskies, and 5 were unidentified. So to identify them, we first placed them in Ziploc bags to get a clear view of them, but eventually we could tell just by picking them up. If we flipped a rock and the salamander got away before we had a chance to capture it, then we put it down as unidentified. One of the coolest things we came across during our research was finding bunches of salamander eggs on the bottom of rocks we flipped. The significance of finding these eggs is that the nest site selection for southern two-line salamanders can help indicate to researchers such as the University of Richmond what environments are beneficial to southern two-line salamanders. If researchers investigate nesting sites, they will also be able to understand how females choose their nesting sites and how they increase the survivorship of their offspring. Southern two-line salamanders are extremely sensitive to their environment and can only live in a select few places. For example, they need to breed and live with close proximity to streams because they use cutaneous respiration. Salamander nest site selection is also affected by the presence of predators and competitors, so that females are best able to guard their eggs and ensure the survival of their larvae. The prevalence of salamanders in every site we sampled indicates that the University of Richmond has a relatively healthy environment considering the recent construction of new buildings and the eco-corridor.
There is a very practical application to the data we collected. This first sample of the biodiversity of salamanders at the University of Richmond that we conducted can be used as a baseline for future investigations as to how healthy our campus's environment is. For example, if more construction is done, future students can conduct the same research we did on streams near that construction site to determine as to whether or not the construction is negatively affecting the ecosystem based on the prevalence of salamanders there. We propose that every year there should be a sampling survey on salamanders conducted that is very similar to ours in order to monitor the University of Richmond's ecosystem health.